Hey guys, welcome back. This is Mr. Shakar again, and I'm ready to do some more awesome math videos. So what we've been doing in the past is we have been multiplying binomials together, and it's been awesome, and I've had so much fun with you. I've been all like, yay, I'm having a good time multiplying binomials. It's so awesome. Those are my teeth, and this is my beard, and this is my hair, and it's all kind of the same thing together, and this is me getting super pumped. Alright, so in the meantime, after we put together binomials, we go ahead and we get something called a trinomial. Why is it called a trinomial? Well, let's try it out. Okay, that was lame. So, yeah, there's three monomials, and that's why it's called the trinomial, okay? So, but what if we have a trinomial and we wanted to break it apart to see what are the factors of it, okay? And if you don't remember what factors are, just real quick, if you remember back in the day, or even like now, you're all like, hey, I've got like, I don't know, 10 out of 30 hot dogs from a 30 pack of hot dogs, okay? You could reduce that down to 1/3 of the pack of hot dogs, okay? And the way we do that is they see that they have a common factor of 10, okay? How many 10s are in this one? Oh, there's one of them. How many 10s are in the denominator? Oh, there's 3 of them, okay? And so that's the idea of factoring. If you remember factor trees, that looked like, I don't know, if we have a number like 24, and I'm looking at a factor tree, I could break it apart into going 2 times 12, alright? And I could break apart 12 again to be 2 times 6. And then I could break that apart again into being 2 times 2 times 3. Okay, all right, and that broke that down into factors. You could also call that prime factors, and you could see since we had 3 of these 2's, you could call that 2 cubed times 3, if you can even read that. But anyway, this is just the idea of factors. You don't have to make factor trees. So if you hate factor trees, don't trip, because we're not making factor trees right now. We are factoring a trinomial, and so this is the type of trinomial. All right. So let's start off with an easier trinomial, and so we're going to follow the pattern of x squared plus bx plus c. And you're like, what is all that action? And I'm about to show you, and you're going to be super excited about it. I'm telling you, you're going to be excited about it. That's when you know that you're going to be excited. When an adult tells you, you will like this, okay? I guess you've already turned off the video by this time, but no, just kidding. So here we are. This is me watching you, all right? Me watching you. Oh. Okay, creepers. All right. So anyway, so here we go. Let's go ahead and break this up. Oh, the idea of breaking this apart is what you're looking for is you're going to try to think of 2 numbers that multiply to make the number that goes right here, but add to make this coefficient that goes right here. Okay. Right now you're all like, what are you talking about? Okay. And so what I'm talking about is, like, let's say I had a number in this trinomial, okay, like this, all right, and this would follow the pattern, and I'll put it right below it, of x squared bx plus c, and this c is a negative 24 in this case, okay? So I'm going to think of 2 numbers that can multiply to make negative 24, but add, when you add them together, they make 2. How is that even possible? Well, I'm about to show you, okay? So I need to think of 2 numbers that make 24. So what are numbers that make 24? Holy moly, we have some numbers here, okay? And so I can think 12 times 2, but unfortunately 12 times 2 don't add to make 2, all right? And since it's a negative, I'm thinking that one of those numbers is going to be a negative, okay? So what are some other numbers that multiply to make 24? Well, I know that 6 times 4 makes 24, but I wonder if one of them was negative, if I'd get a positive 2. Oh, what if I had positive 6 times a negative 4? Would that give me a negative 24? Yes, it would. And you're super pumped about that. Okay? And then I can also think that the 2 of those would add to make positive 2. What? So, here we go. The idea is going to break down like this. In order to get the x squared, I know that I'm going to have 2 binomials, because I'm working with binomials, alright? It's going to be x times x, alright? Which is what we've been doing, and I'm going to be multiplying it times 6, x plus 6, and x I can say plus negative 4, but I'm just going to say x minus 4. Okay? And if I were to FOIL these out, I think that would prove to end up with this trinomial. Let me just double check. Oh my gosh, I did it in the previous video. And I see here that x plus 6 times x times negative 4, following the pattern of the distributive property, gets us down to x squared plus 2x minus 24. Now the issue is, let me give you a different way of solving a problem like this. Let's say I had something that looked like x squared plus 8x plus 12. Okay? And like I said, I'm trying to think of two numbers that multiply to make 12 and add to make 8. Okay? But let me just show you another way of solving for this underneath Creepy Shock over here. Alright? And I'm going to call this the x factor. Alright? Kind of like a really bad TV show. So, I didn't write it here, but the coefficient that goes next to the x squared is actually an a. Now a is represented by the number 1 for now, because there's nothing written there. How many x squareds are there? There's 1 x squared. So what I will go ahead and put in over here is, and this is the way we can do this, I can do whatever a times c, oops, sorry, let's fit that, a times c will go up in the top of my x factor, alright? And then whatever my b is going to go in the bottom. So that's a b that's going to go down there. Okay? Now let's actually do the real example of this. So, x factor. In this case, my a is 1, and my c is 12. Okay, so 1 times 12, I'll let you work that out for the next 5 minutes. Right, it's 12. Okay? And then my b is positive 8. And I'm trying to think to myself, what are two numbers that multiply to make 12, but add to make 8? I wonder, 6 and 2. That works out for multiplying, and it works out for adding. So, check this out. I now have x times, these are going to be my binomials, okay, multiplying with each other. And I'm going to have x plus 6, because that's a positive 6, and x plus 2. And these are going to give me my, my factors of x squared plus 8x plus 12. Okay? So that's using the x factor system. Okay? So I hope that is helpful. Now to finish this out, if I know that this equation is equal to 0, I can actually solve for x. Okay? And we've already gone over this in class, but the idea is this. If I know this equals 0, alright, I can go ahead and say, well, if these two multiply together to equal 0, that must mean that either this binomial is equal to 0, or this binomial is equal to 0. So therefore, what would make x plus 6 equal 0? So I can think to myself, x plus 6 equals 0, and x plus 2 equals 0. What would be the values of x? Well, in this case, I would have to isolate x, subtracting 6, and I'd get x equals negative 6. In this case, I would subtract 2 from both of them to isolate x. That would cancel out and end up with x equals negative 2. So my two values for x would be negative 6 or negative 2. Okay? These are my two values, my two possibilities for the value of x. Okay? That is awesome. Hey everybody, thanks for watching. Hope you have a great evening. And if you can send me some likes or subscribe, that would make my day. Thanks. Happy birthday.